Wooden water pipes script, ready for voiceover. In 2018, a construction crew in Philadelphia was digging a trench for a new fiber optic cable. About 6 feet down, their excavator hit something that shouldn't have been there. Not a gas line, not a sewer pipe, a hollowed-out tree trunk, 12 feet long, still wet on the inside. That log had been carrying drinking water beneath the streets of Philadelphia for over 200 years. The crew called the city called a historian. And the historian confirmed what the workers already suspected. They were looking at a piece of American infrastructure older than the Constitution itself. A wooden water main, bored from a single white pine log, sealed with iron bands, buried in the dirt before George Washington took office. And here's what makes this genuinely remarkable. That pipe was still holding water. After 2 centuries underground, in soil that freezes and thaws, expands and contracts, unsurrounded by roots and rocks and the vibrations of a city that grew up around it, the wood had not rotted. The seals had not failed. The water inside was still flowing to wherever the pipe connected before someone accidentally severed it. This isn't a one-time discovery. Construction crews across the eastern United States find these wooden water mains every single year. Boston, New York, Baltimore, Richmond. Buried beneath the oldest neighborhoods, under cobblestone streets and colonial-era foundations, there are miles of hollowed-out logs still sitting in the earth. Some are empty, abandoned when cast iron took over, but others, in a few documented cases, were still connected to active water systems well into the 20th century. The last known wooden water main in service in the United States wasn't removed until 1962. Think about that timeline. America put men on the moon 7 years after we finally stopped using wooden pipes to deliver drinking water in some cities. This is the story of how America built its first water infrastructure from trees, how thousands of workers spent their lives boring holes through solid logs by hand, laying pipe in trenches they dug with shovels, and creating pressurized water systems that engineers today still study with genuine respect. This is about the men who built something essential and were almost entirely forgotten. And it's about the strange, humbling experience of digging into the earth and finding their work still there, still intact, still holding water after everyone who made it has been dead for 150 years. Before we can understand why anyone would build a water system from wood, you have to understand what American cities looked like in the late 1700s. Picture Philadelphia in 1790, the largest city in the new nation, population around 45,000 people, which made it one of the biggest cities in the entire Western Hemisphere at the time. The streets were unpaved. The buildings were mostly wood and brick, and there was no running water. None. Not for the rich, not for the poor, not for anyone. If you wanted water in Philadelphia in 1790, you had 3 options. You could walk to a public well and carry it home in buckets. You could pay a water carrier to bring it to your door, or you could collect rainwater in barrels and hope it didn't run out during a dry spell. The public wells were the most common source. Every neighborhood had a few of them, dug deep enough to hit the water table, lined with stone to keep them from collapsing. And the water from these wells was killing people. Nobody understood germ theory yet. Nobody knew that the same soil that filtered groundwater also contained seepage from the city's cesspits, from the slaughterhouses, from the tanneries, from the graves in the overcrowded churchyards. People drank from wells that were contaminated with human waste, animal waste, industrial runoff, and decomposing organic matter. They got sick constantly. Dysentery, typhoid, cholera. These diseases swept through American cities every few years, killing hundreds or thousands of people each time, and no one could figure out why. Philadelphia's water problem became impossible to ignore in 1793. That was the year yellow fever hit the city and killed nearly 5,000 people in 4 months. 10% of the population dead. The rich fled to the countryside. The poor had nowhere to go. Bodies piled up faster than they could be buried. Yellow fever is actually spread by mosquitoes, not contaminated water. But in 1793, nobody knew that. What they did know was that the city was filthy, the water was suspect, and something had to change. The yellow fever epidemic created the political will to do something that had been discussed for years but never acted upon. Philadelphia needed a real water system. Clean water, piped in from outside the city, delivered reliably to every neighborhood. The question was how to build it. Cast iron pipe existed in 1793. The British had been making it for decades, but cast iron was expensive, difficult to manufacture, and almost entirely imported. The new American nation didn't have the foundries, or the skilled workers or the capital to produce cast iron pipe at scale. Buying enough from England to supply a major city would cost more money than existed in the entire Philadelphia treasury. But wood was everywhere. The forests of Pennsylvania stretched for hundreds of miles in every direction. White pine, hemlock, oak, chestnut. Trees so massive that a single trunk could yield multiple 12-foot pipe sections. Trees so abundant that they were being cleared anyway to make room for farms and settlements. The raw material for a wooden water system was essentially free. All you needed were the tools to shape it and the workers to install it. This wasn't a new idea. Wooden water pipes had been used in Europe for centuries. The Romans had experimented with them. Medieval cities in Germany and England had built entire water systems from board logs. The technology was proven. The question was whether it could work at the scale Philadelphia needed. In 1799, the city hired Benjamin Henry Latrobe, an English-born architect and engineer, to design and build the first municipal water system in America. Latrobe had studied hydraulic engineering in Europe. He understood pumps, pressure, and the behavior of water in enclosed systems, and he understood something else that would prove essential. He understood that the success of the project would depend entirely on the quality of the wooden pipes. The process of making a wooden water pipe started in the forest. Workers called log pickers would walk through the timber stands looking for specific trees. Not just any tree would work. The ideal pipe log was white pine, straight-grained, with no major knots or defects, at least 18 inches in diameter, and free of rot or insect damage. Finding trees that met all these criteria took skill and patience. A good log picker could evaluate a tree in seconds, reading the bark, the shape of the trunk, the way the branches grew, and knowing immediately whether the wood inside would hold up under pressure. Once a suitable tree was identified, a crew of fallers would bring it down. In the late 1700s, this meant 2 men with a crosscut saw, working for hours to cut through a trunk that might be 3 feet across. The tree would fall with a sound like thunder, shaking the ground, sending smaller trees crashing down with it. Then the limbers would move in, stripping off the branches with axes, leaving a bare trunk that might be 60 or 80 feet long. This trunk would be cut into sections, typically 12 feet each, though some systems use shorter or longer pieces depending on the terrain. Each section was called a stick. A single large tree might yield 4 or 5 sticks. A small one might yield only 2. These sticks then had to be transported to the boring mill. In areas with rivers, this meant floating them downstream. In areas without water transport, it meant dragging them overland using teams of oxen. Either way, the labor was brutal. A 12-foot section of green-white pine, 18 inches in diameter, weighs close to 800 pounds. Moving hundreds or thousands of these sticks required an enormous workforce and took months or years. At the boring mill, the sticks were transformed into pipes, and this is where the real craftsmanship began. The boring process used a tool called a pod auger. Imagine a long iron rod, sometimes 20 feet or more, with a cutting head at one end shaped like a half-cylinder with a sharpened edge. This rod was mounted horizontally on a frame, and the log was positioned in front of it, also horizontal, held in place by wooden cradles and iron clamps. A team of 2 to 4 men would turn a large wheel connected to the auger by gears. As the wheel turned, the auger rotated and advanced slowly into the end of the log. The cutting head would shave away the wood at the center of the trunk, creating a round hole that grew deeper with each revolution. Boring a single 12-foot log took anywhere from 2 to 8 hours, depending on the hardness of the wood, the sharpness of the tools, and the stamina of the workers. The men turning the wheel worked in shifts, switching out every 15 or 20 minutes because the labor was exhausting. Meanwhile, another worker would periodically withdraw the auger to clear the wood shavings from the bore, a process called spooning out. The size of the bore varied depending on the purpose of the pipe. Main lines that carried large volumes of water might have 6-inch or 8-inch bores. Smaller distribution lines might be bored to 4 inches or even 3. The outside diameter of the log stayed the same, which meant the wall thickness varied. A 3-inch bore in an 18-inch log left massive walls, nearly 7.5 inches thick on each side. This gave the pipe tremendous strength. Keeping the bore straight was one of the great challenges of the process. If the auger drifted even slightly off-center, the bore would exit through the side of the log somewhere before reaching the other end, ruining the entire piece. Unskilled auger men developed techniques to feel the tool's progress through the wood, adjusting pressure and speed to keep the cut true. Even so, a significant percentage of logs were lost to crooked bores, especially when working with wood that had hidden defects or irregular grain. Once both ends of the log were bored and the holes met in the middle, the pipe was essentially complete, but it still needed to be connected to other pipes to form a continuous system. This was done using a joint called a taper and socket connection. One end of each pipe was shaped into a tapered point, narrowing down to fit inside the bore of the adjacent pipe. The other end was left at full diameter or slightly widened to receive the taper from the next pipe in line. When the pipes were joined, the taper would slide into the socket, and the whole assembly would be driven together with a heavy mallet until the fit was tight. To make the joint watertight, your workers would wrap the tapered end with oakum, a fiber made from old rope that had been picked apart and soaked in tar. This oakum packing would compress as the joint was driven home, filling any gaps and creating a seal. Additional waterproofing came from iron bands, heated and fitted around the joint while red hot. As the iron cooled, it contracted, squeezing the joint even tighter. These joints were the weak points of any wooden water system. Over time, the oakum could deteriorate. The iron bands could rust. Ground movement could shift the pipes and break the seals. Most leaks in wooden water systems occurred at the joints, not in the pipes themselves. And finding and fixing these leaks, buried underground, was one of the most difficult maintenance challenges the early water companies faced. With the pipes manufactured and ready, the next phase was installation. This meant digging. A typical wooden water main was buried 3 to 5 feet underground, deep enough to protect it from frost in winter, shallow enough to be accessible for repairs. Digging a trench this deep by hand through whatever soil and rock happened to be present was backbreaking work that employed thousands of men across American cities in the early 1800s. The workers were mostly immigrants and day laborers, Irish, German, free black men, whoever was willing to do the most grueling physical labor for the lowest wages. They worked in crews of 8 to 12, right with picks and shovels, moving down the planned route of the water main a few feet at a time. One group would break up the soil with picks, another would shovel it out of the trench, a third would haul it away in wheelbarrows or carts. In soft soil, a good crew could dig 20 or 30 feet of trench per day. In rocky ground, they might manage only 5 or 6 feet. And in cities, where they were digging through streets that had been built up and paved over for decades, and they encountered constant obstacles, old foundations, abandoned wells, cesspits that had been covered over and forgotten, the bones of animals and sometimes humans buried in unmarked graves. The trenches were dangerous. Cave-ins were common, especially in wet weather when the walls became unstable. Men were buried alive. Others were crushed when heavy pipes rolled off their cradles during installation. Still others were injured by the sheer physical strain of the work, the hernias and broken bones and backs that gave out before their owners turned 40. We don't have comprehensive records of how many workers died building America's early water systems. The deaths of laborers weren't considered newsworthy. The men who died were often buried without ceremony, their names unrecorded, their families left without income or support. What we know is that the work was constant, the conditions were harsh, and the casualties were significant. Once the trench was dug, the pipes were lowered in. This required careful coordination. Each 12-foot section had to be positioned so its socket end faced the direction the water would flow, ready to receive the taper from the next pipe. The pipes were set on beds of gravel or sand to provide drainage and prevent settling. Then the joints were made, the oakum packed, the iron bands heated and fitted. Testing came next. Water was introduced into the completed section, and workers would walk the length of the pipe, all looking and listening for leaks. Any joint that sprayed or dripped had to be repacked. Sometimes this meant excavating a section that had already been partially backfilled, redoing the joint, and starting over. A single major leak could set a project back by days. When the testing was complete and the section was declared sound, the trench was backfilled. The dirt that had been removed was shoveled back in, layer by layer, and tamped down to compact it. The surface was restored to whatever state it had been in before, whether that was bare earth, gravel, cobblestone, or brick. And the water main, invisible now, began its silent work. Philadelphia's system was the first, but it wasn't the last. By 1820, wooden water mains were carrying water beneath Boston, New York, Baltimore, Richmond, Charleston, and dozens of smaller cities and towns. The basic technology was the same everywhere, though local conditions created variations. Cities with access to large pine forests used pine. Cities near chestnut or oak forests used those species instead. Some systems use longer pipe sections, others use shorter ones. But the fundamental approach, hollowed logs connected by tapered joints and sealed with oakum and iron, spread across the eastern seaboard and became the standard way American cities delivered water for nearly a century. The systems grew constantly. As cities expanded, new mains were laid to serve new neighborhoods. Existing mains were connected to create networks. Pumping stations were built to push water uphill or to maintain pressure at distant points. The maps of these systems, where they survive, show intricate webs of lines spreading out from central reservoirs like the roots of trees, which is fitting given what the pipes were made from. And the systems worked. They worked well enough that people stopped dying of waterborne diseases at the rates they had before. They worked well enough that cities could grow, adding tens of thousands and then hundreds of thousands of residents, all of whom needed clean water every day. They worked well enough that the wooden pipes, meant as a temporary solution until iron became affordable, stayed in the ground for generation after generation. But wood has limits. The first major limitation was pressure. Wooden pipes could handle moderate pressure, the kind generated by gravity from a reservoir on a hill or a modest pump. But as cities grew and buildings got taller, the systems needed to deliver water at higher pressures to reach upper floors in distant neighborhoods. Wooden pipes began to fail under this strain. The joints leaked, the walls cracked. Sections that had been sound for decades suddenly gave way. The second limitation was fire. American cities in the 19th century burned with terrifying regularity. New York in 1835. Chicago in 1871, Boston in 1872, San Francisco in 1906. Fighting these fires required water, lots of it, delivered at high pressure through hydrants scattered throughout the city. Wooden water mains couldn't deliver the flow rates or pressures that fire departments needed. When a major fire broke out, the wooden systems were overwhelmed, and entire neighborhoods burned, because there wasn't enough water to stop the flames. The third limitation was maintenance. Wooden pipes could last a remarkably long time under ideal conditions, but conditions underground are rarely ideal. Tree roots grew into the pipes, seeking the moisture inside. Ground settlement shifted the joints. Freezing and thawing cycled, stressed the wood. And over decades, even the best preserved pipes eventually began to rot from the inside out. By the 1830s and 1840s, American foundries had finally developed the capacity to produce cast iron pipe at scale. The technology had existed for decades, but now the economics worked. Iron was still more expensive than wood per foot, but iron pipes were stronger, handled higher pressures, required less maintenance, and lasted longer. Cities began replacing their wooden mains with iron, starting with the highest pressure lines and the most critical infrastructure. This transition took decades. It was expensive, and most cities couldn't afford to replace everything at once. So they replaced pipes as they failed, which meant wooden and iron pipes coexisted in the same systems for years. A main might start at a reservoir in cast iron, transition to wood in an older neighborhood, switch back to iron where the line passed under a major street, and end in wood again at its terminus. The maps from this era show a patchwork of materials, each section reflecting the state of technology and the city's budget at the moment it was installed. The last wooden water mains in regular service were typically in small towns or remote areas where the economics still favored wood into the early 20th century. But even in major cities, wooden pipes sometimes stayed in the ground far longer than anyone expected. In 1911, a crew repairing a street in Boston found a wooden water main that was still connected to the active system. The pipe had been installed in 1796, 115 years earlier. It was still carrying water. The wood was sound, the joints were intact. The crew documented the find, disconnected the pipe, and replaced it with iron. But they noted, with evident surprise, that there was nothing functionally wrong with it. The pipe was replaced not because it had failed, but because the city was standardizing on iron for administrative convenience. Similar discoveries happened throughout the 20th century. A wooden main found in New York in 1929, another in Philadelphia in 1957. The pipe in New Jersey that wasn't removed until 1962. Each time, the same story. Workers digging for some other purpose would hit wood instead of iron. They would call supervisors. The supervisors would call engineers. And everyone would stand around the open trench, looking at a piece of history that had quietly continued doing its job, while the world above it changed beyond recognition. The engineers who examined these pipes were often amazed by their condition. Wood that had been underground for a century or more showed little sign of decay. The interiors were smooth, sometimes coated with mineral deposits, but otherwise intact. The explanation lies in the environment. Buried below the frost line, saturated with water, deprived of oxygen, wood doesn't rot. The same conditions that preserve ancient shipwrecks and waterlogged archaeological sites preserve the wooden water mains. As long as the pipes stayed wet and sealed, they could last essentially forever. Some pipes found in the 20th century were sent to museums or universities for study. Researchers sectioned them, examined the wood under microscopes, analyzed the mineral content of the interior coatings. They found evidence of remarkable preservation. Cellular structures intact after 200 years. Original tool marks still visible on the bore surfaces. The science confirmed what the field observation suggested. These pipes were built to last, and they did. But even as the last wooden mains were being removed from active service, new discoveries were just beginning. The explosion of urban construction in the late 20th and early 21st centuries has brought wooden water pipes back to public attention. Every time a city digs up a street for a new subway line, a fiber optic cable, a gas main, or a sewer upgrade, there's a chance of hitting wood. The pipes are still down there, tens of thousands of feet of them, and abandoned in place when they were disconnected from the water system generations ago. Most of these discoveries go unreported. A construction crew hits wood, realizes it's not connected to anything, removes it or works around it, and continues with the job. The wood goes to a landfill or a scrap pile. No one documents it. No one studies it. The artifact that someone spent hours boring by hand, that a crew of laborers buried in a trench they dug with shovels, that carried drinking water to a growing city for decades, gets thrown away like debris. But sometimes the finds are significant enough to attract attention. In Philadelphia, a 12-foot section of wooden main discovered during a construction project in 2018 was donated to the Philadelphia Water Department. The department has it on display at their headquarters, a tangible reminder of the system's origins. Similar sections are preserved in museums in Boston, New York, and other cities with long water supply histories. And occasionally, researchers go looking deliberately. Urban archaeologists have used historical maps and records to locate sections of abandoned wooden main that were never removed. Some of these projects have recovered intact pipe runs of 50 feet or more, complete with original joints and iron bands. These finds provide invaluable data about early American manufacturing, labor practices, and engineering standards. What does it mean that we built our cities on wooden pipes? It means that the infrastructure we take for granted, the ability to turn a tap and receive clean water, didn't begin with high technology. It began with trees and hand tools and the physical labor of thousands of men whose names we'll never know. It means that engineering problems have always been solved with whatever materials were available, not whatever materials were ideal. It means that the desperation of a city watching its citizens die of waterborne disease, can drive innovation that lasts for generations. And it means that the ground beneath American cities holds more history than most of us realize. Every street you walk on, every building you enter, sits above layers of buried infrastructure from different eras. Iron pipes from the 1850s, brick sewers from the 1880s, electrical conduits from the 1920s. And beneath all of that, if you dig deep enough in the right places, the wooden water mains that started it all. The men who bored those logs by hand, who turned the auger wheels until their arms gave out, who lowered the heavy sections into trenches and packed the joints with oakum and drove the iron bands into place. They didn't think they were making history. They were just trying to earn a day's wage, doing hard work that someone had to do. They went home at night exhausted, covered in sawdust and mud, and woke up the next morning to do it again. Most of them are buried in unmarked graves now. The churches where their funerals were held have been torn down. The neighborhoods where they lived have been rebuilt 4 or 5 times over. Their descendants, if they have any, don't know their names or what they did, but the pipes are still there. Every so often, when the city digs in the right place, we find them. We stand at the edge of the trench and look down at wood that was shaped by human hands before the Industrial Revolution. Before the Civil War, before electric lights, before automobiles, before everything we think of as modern. And for just a moment, we're connected to the workers who made it. They didn't know that their work would last this long. They couldn't have imagined the cities that would grow up around their pipes, the millions of people who would benefit from the water those pipes carried, the centuries that would pass before anyone dug them up again. They just did the work, and they did it well, and then they disappeared into history like almost everyone does eventually. The wooden water pipes of America are a monument to that work, not a monument anyone built on purpose, not a monument with a plaque or a dedication ceremony. Just the work itself, buried in the ground, waiting to be discovered, still holding together after everyone who made it is gone. That's the kind of monument that means something, not the kind that celebrates great men or great events, the kind that just lasts, the kind that does its job, silently, invisibly, for longer than anyone expected, the kind that reminds us that progress isn't built by individuals. It's built by thousands of people doing unglamorous work, one day at a time, one pipe at a time, one trench at a time. The next time a construction crew in Philadelphia or Boston or New York hits wood instead of iron, they might call the city. They might call a historian. Or they might just toss the pipe aside and keep digging. Either way, the work endures. Either way, the water flowed. Either way, the men who built it made something that mattered, even if they never knew it would. That's the story of America's wooden water pipes, a story of desperation and innovation, a story of grueling labor and remarkable engineering, a story of infrastructure that outlasted the people who built it, the tools that shaped it, and the world that created it. And somewhere beneath the streets of the oldest American cities, that story is still written in wood, still waiting to be found, still holding water, maybe, after all these years. Still, the work of hands will never shake, faces will never see, names will never know. That's worth remembering. That's worth knowing about. Because the next time you turn on a tap and water comes out, you're connected to something that started with trees and hand tools, and men who gave their bodies to work that no one would remember. The water still flows. The debt remains. And the wooden pipes, silent in the darkness, hold the memory of what it cost.